Welcome to this course on Mathematical Foundation of Robotics. Uh, this is the lecture 0, and in this lecture I just want to give a motivation for this course. So why do we need mathematics for dealing with robots? Why do we need the mathematical language to discuss all possible interactions of a robot with the world? So let's start by giving a definition of robot, which will be the definition that we will be using. A robot for us is an intelligent connection between perception and action. In fact, we can think of a robot as a physical system which is provided with some way of interacting physically with the world and also some sensors to perceive the world itself. So we can say that the robot can be thought as an agent that acts on the world and receives information from the world through another process which we'll call perception. So the action is represents all the physical interaction that the robot is having with the world itself, and instead the perception is a process through which the robot tries to understand the world and also the effects of its own action, and as a consequence of that it will try to decide its course of action on the world itself. Now these two processes, perception and action, are indeed very complicated. So we need to cast these two types of interaction, both action and perception, in very precise terms. And for us, precise means mathematical terms, in order to understand all the implications and to fully understand the complexity of these interactions. In fact, we can say with Wittgenstein that what we cannot speak about clearly, then we should pass over in silence. And for us, clearly means mathematical terms. In other words, for us, mathematics will be nothing else than a language that will help us to fully understand all the implications of our analysis on these two interactions that the robot is having with the world itself. So, but that said, mathematics is just a language. So the interpretation of these analysis that we are going to give, it's something that it is not the job of mathematics, but will be the job of the robotic engineer. So we will be using math to express all these interactions, but then we'll go back to robotics to fully understand what is the meaning of those interactions. Good. So what are the branches of mathematics that we will be investigating in order to set these mathematical foundations? We'll be investigating analysis and linear algebra. Uh, Both of these will have a large impact on our analysis, and at the intersection between linear algebra and analysis, and exactly in this intersection, we will find differential geometry, which will be the most advanced topics that we will study in our course and will be a crucial ingredient to understand the control of robots. Let's get now a few details about what will be for each single part an overall program. Um, as far as the analysis part is concerned, we will study the preliminaries, where we will be reviewing some elementary math and that we need to just start talking about analysis. Then we'll introduce the concept of limits and apply these concepts to sequences and series. Then we'll pass on to differential calculus, and in particular we will apply differential calculus to the study of functions. And then finally we will delve into integral calculus, which means integrals and differential equations. Then we'll move to linear algebra, and within this other part of the course we will be investigating basically four parts of linear algebra, namely vector spaces, and linear maps, then analytic geometry, then we'll study linear systems, and finally scalar products. Okay, so this is an overall a top view of all the topics that we will be developing within this course, and I'll try in every of this part of the program to keep alive the connection with our robotic application as far as possible. So thank you for listening to this, and I'll see you for the lecture 1 in analysis. Thank you.